Welcome to Formula 1 Maths. This is exercise 10.4, GCE A-Level Applied Maths, Year 1. Exercise 10.4 is on motion in 2 dimensions. We've got 3 questions to answer. Question 1. The forces 3I plus 5J newtons and Pi plus Qj newtons act on a particle P. The resultant of the 2 forces is R. Given that R act in a direction parallel to the vector minus 2I plus 4J, show that 2P plus Q plus 11 is equal to 0. So the resultant of these 2 forces is given by 3I plus 5J plus Pi plus Qj. This vector is parallel to this vector. So let me draw this vector here. And so that is the vector minus 2, 4. I can draw another vector which is parallel to this and say that because this vector is parallel to this, I can represent this vector by some constant k times this vector. So that will be minus 2, 4. Now the value of k will determine how long or how short this vector is and also the direction. If k is negative, the direction will change to the opposite of this vector. If k is between 0 and 1, then this vector will be shorter than this vector. If k is more than 1, then this vector will be longer than this vector. In any case, the 2 will be parallel. So we can go and say that R, which can now be written as P plus 3, Q plus 5, will be equals to some constant times minus 2, 4. Then this will generate 2 equations. The first one will be P plus 3 is equal to minus 2k. And the second one will be P plus 5 is equal to 4k. We can now solve these 2 equations, equation 1 and 2, simultaneously by multiplying the first equation by 2 to get 2p plus 6 is equal to minus 4k. Then we can go and add the second equation, equation 2, which will be 2p plus q, 6 plus 5, which will be 11, and minus 4 plus k equals to 0. And so that's question 1. Question 2. A particle of mass 2 kilograms is acted upon by a force R of 5I plus bj newtons on a bearing of 45 degrees. If the particle starts from rest, A, find the value of B, calculate the magnitude of R, C, work out the magnitude of the acceleration of the particle, D, find the total distance traveled by the particle during the first 4 seconds of its motion. So first of all, let's draw a diagram, and this is north, and therefore this will be east. The north and east corresponds with the J direction and the I direction, respectively. We can now draw our vector as follows. We can do this because we are told that the vector R is on a bearing of 0, 4, 5. That means this angle here is 45. It also means that this angle is also 45 because this angle is 90. So this angle is 45. I can now put in the components of R as follows. I have 5I horizontally, bj vertically. I can now find the value of b as follows. Tan 45 is equal to b over 5, opposite over adjacent. That means b is equal to 5 tan 45, and because tan 45 is 1, b is equal to 5. And so that's the value of b. For question 2b, calculate the magnitude of R. So R now is 5I plus 5j newtons. We can therefore use Pythagoras theorem to calculate the magnitude of r as follows. So the magnitude of r is given by the square root of 5 squared plus 5 squared, and that will yield 25 times 2, the square root of 25 times 2, and that gives 5 root 2 newtons. So the magnitude of r is 5 root 2 newtons. For question 2c, work out the magnitude of the acceleration of the particle. This is where we go and use Newton's second law of motion, which states that F is equal to ma, where F is the resultant force on the particle, m is the mass, and a is the acceleration. We know the force acting on the particle is 5 root 2 newtons. We also know the mass, which is 2 kilograms. And so we can do a simple substitution as follows. 5 root 2 is equal to 2a. Rearrange to solve for a, and you get a is equal to 5 root 2 over 2 meters per second squared. And that will reduce to 3.54 meters per second squared. For question 2d, find the total distance traveled by the particle during the first 4 seconds of its motion. The particle starts from rest. That means u is 0. It travels for 4 seconds. So t is 4 seconds. The acceleration we have calculated, and we know is 5 root 2 over 2 meters per second squared. So we've got u, we've got t, we've got a, we're looking for s. So the Silva equation we're going to use will be 3. S is equal to ut plus half at squared. So let's put it down and do our substitution. And this is what we get. S is equal to 0 because u is 0. 0 times 4 is 0. Plus half times acceleration, 5 root 2 over 2, and the time squared. And this will reduce to S is equal to 5 root 2 over 4 times 16. You can reduce this fraction by cancelling out. 4 goes here 1, 4 goes there 4, and that will reduce to 20 root 2 meters. Simplifying gives 28.3 meters. Question 3. 3 forces. F1, which is 8 minus 1, which is the same as 8i minus j. F2, 6 minus 5, same as 6i minus 5j. And F3, minus 2, 0, which is minus 2i, act on a particle with mass 6 kilograms, which is at rest. A. Find the magnitude and direction of the acceleration of the particle. B. Find the time taken for the particle to travel a distance of 15 meters. So for A, the resultant force acting on this particle will be F1 plus F2 plus F3. And so we get this. And this will therefore be equal to 12i minus 6j. We can now go and use Newton's second law, which says that F equals to ma, where F is the resultant force acting on the particle, m, the mass of the particle, and a, the acceleration. We know the resultant force, which is 12i minus 6j, and we do the mass, which is 6 kilograms. So we can do our simple substitution as follows. 12i minus 6j is equal to 6a. We can now do some vector algebra and get the following. A will be equal to 1/6 of this vector here, 12i minus 6j. And this will reduce to 2i minus j. Because when we have a scalar multiplying vector like this, 1/6, 12i minus 6j, this will be equal to 1/6 times 12, 1/6 times minus 6. This will cancel here, 2, and this will cancel here, 1. And this is why we got 2 minus 1, which is the same as 2i minus j. And so, using this vector, we can calculate the magnitude by using Pythagoras' theorem, which will be the square root of 2 squared plus minus 1 squared. That will give square root of 4 plus 1, and finally, square root of 5 meters per second squared, which will also be 2.24 meters per second squared. For the direction, we need to do a sketch. So that's north, and therefore this is east. And these corresponds with the I and j directions. We can now draw this vector 2i minus j as follows. For the direction, we need to calculate this angle here. Let's call this angle theta, and to calculate this angle, we need to put in the components, which are 2i horizontally and 1j vertically going south. We can now use SOHCAHTOA to calculate the angle theta. So tan theta is equals to 1/2, opposite over adjacent. That means theta is equal to tan inverse of 0.5, which we gave 26.6 degrees. So it means that theta is 26.6 degrees over here. But for the bearing, we need to add 90 to 26.6 degrees, because this angle is 90 and the bearing is always measured from the north, and we are going to get 116.6. So the bearing, and therefore the direction, is 117 degrees. The particle starts from rest. That means u is 0. We have just calculated the acceleration, which has a magnitude of square root of 5 meters per second squared. We also know that it traveled a distance of 5 meters. We are required to find the time. So we know u, we know a, we know s, we want t. The Sjouvart equation that we are going to use will be equation 3. S is equals to ut plus half at squared. So let's do our substitution, and we are going to get 15 is equals to 0 plus half times root 5 times t squared. This will simplify to 30 is equals to root 5 t squared. And so t squared is equal to 30 over root 5. We need to find the t, so we'll find the square root to give us t, and therefore t will be the square root of 30 over square root of 5. This will yield 3.67 seconds. And that is the time required for the particle to travel 15 meters. And this is the end of this set of questions on exercise 10.4.